example, do we remember how to simplify square roots? Okay, well, I'm glad you asked because we're going to have a quick refresher. Because there are certain things that we have to be able to do with square roots going forward, because we're going to do a lot of them. Whether it is simplifying the square roots or whether it is what we call rationalizing the denominator, which is all things that I know that you guys have done. For example, when we simplify a square root, we're looking at basically these. If I'm looking at the square root of 24, and I need to simplify that guy by hand, I need to search and think about what is a perfect square that goes into 24. Remember, when you're looking for perfect squares, you're trying to see, is it divisible by 4, 9, 16, 25, and so on and so on and so on. Is 24 divisible by one of those numbers? Which one? 4. So remember, when you're dealing with square roots, you can rewrite them as a composite of other numbers, because that's what numbers are. They're all multiples and things and stuff. So in your mind, you're technically doing this. The square root of 4 times the square root of 6. What's the square root of 4? 2. So your answer here would be 2 and 6. Okay? Again, that's stuff that I know that you have seen. I know that is stuff that you have done. Whether you remember it, that's another story. Let's just hope that you did. Same thing with 90. What's going to be the perfect square? 9. Right? So if you take out and you write it as 9, or square root of 9 and square root of 10, you get perfecto. Okay? When it gets to fractions, when it gets to division, things like that, what do you do with the square root symbol? Do you remember? It goes to both numbers. You square root the numerator, you square root the denominator. They just don't separate them. Okay? What happens when we... Anyway, so what happens here is this is the same as saying the square root of 7 divided by the square root of 16. Well, can you simplify any of that? Yeah, what's the square root of 16? 4. So my answer here would be root 7 over 4. Bless you. When it gets to ones like these, though, this is when the math etiquette comes into play. Math etiquette, if you remember. Last year in right triangle trig stuff, you guys had a lot of 30, 60, 90 triangles, 45, 45, 90 triangles, and sometimes you had to divide up by the square root of 3. When you did that, you would rationalize the denominator because it is not proper form, it's not proper etiquette or math etiquette, if you will. That's a made-up vocab word for those who work in vocab today. See, I told you vocab. Anyway, when you have this rationalized form, what you wind up doing is this. You have square root of 7, square root of 2. You don't want roots in the denominator. Okay? So what we do is we multiply this fraction by a factor of 1. And what we do is we actually multiply it by the actual root. So when you multiply square root of 2 times the square root of 2, what do you get? 2. Remember, square root of junk times the square root of junk is always junk. So it doesn't change the value of this when you multiply it by root 2 over root 2, because that is just multiplying by 1. It's just a weird way of writing the number 1. So when you multiply that out, you get root 2 times root 2, which is root 4, which makes it 2. And then root 7 and root 2 is root 14, and you're done. Okay? Again, it's stuff that you'll see from time to time. It's not going to be numbers you're going to see a lot of 27s, 42, 90s, numbers that won't be horrible that you can't figure out. Okay, it's not going to be overwhelmingly or not overwhelming. It's not going to be overwhelming to do it. It's going to be fairly straightforward. Okay? The reason why I wanted to show you guys this stuff first is because as we get into today's things, we're going to be solving equations like this. And when we solve equations that look like this, these are not factored equations. Okay? These are just quadratic equations with just the x squared term. So what I want to do, excuse me, is solve for x. And when you solve for x, remember, you're using your order of operations in reverse. It's no longer PEMDAS, it is now the, remember SADMET? It's backwards. PEMDAS is backwards. So if you work backwards, first thing you try to do is you have to undo subtraction, undo addition, undo multiplication, undo division, so on and so on. You're just working backwards like you would normally. What would you do first here? Undo the addition, right? You would just subtract the 1. Are we okay with that? Okay. You work backwards like you would any other equation. All right, 2x squared. Now what? You have to get everything away from the x value prior to taking any square roots. It cannot have a coefficient in front of it except for being 1. Okay? So now I've got x squared equals 8, which means how do you undo squaring? You square root. Now here's the kicker. When you square root something, you're looking for a number that you multiply together, that it multiply by itself, excuse me, I can speak, that gives you the number 8. Well, 2 positive numbers was created, or 2 negative numbers. So whenever you take a square root over an equal sign, the rule is plus or minus. Does that vaguely ring a bell? Anytime you take a square root over an equal sign, you have to do a plus minus because there are 2 values that will work. Okay. Now in this case, can I simplify the square root of 8? Yeah, what do you get? 2 or 2. 8s, 12s, 18s, those are the ones that you guys should know off the top of your head. It's pretty quick and painless. So your value would be plus or minus 2 root 2, and you go on your happy way. Not terrible. It's just a matter of working backwards. I know that it's just another, it's basically adding, instead of a 2-step equation, it's like 3. Okay. What do you do now? Besides try. Don't try. So you have 1/3 times the quantity x plus 5 squared is 7. Yeah. How would you undo multiplying by 1/3? Multiply by 3. Very good. Use reciprocals. To undo multiplying by 1/3, you would multiply by its reciprocal. Because 1/3 is the same thing as saying divided by 3. Since that binomial is it's junk squared and there's nothing after it, I can just multiply both sides by 3 and get rid of the fraction. Okay. Multiply both sides by 3, and now you're at x plus 5. Quantity squared is 21. So what do you do now? Square or square root? Square root. Yeah. Because now I've got junk squared. So how do you undo squaring junk? You square root it. Now remember, the square root of junk squared is junk. So what's the junk in the parentheses? And I got to make sure I have plus or minus root 21 there. What do I do to move the 5? Subtract it. Now, when you've got the radicals and the plus minuses on the right-hand side, anytime you move something to it, you put it first. The proper etiquette form is to put that -5 in front of the plus minus. You put whole numbers, integers, prior to plus minus with roots. It's just kind of the, like again, it's the mathematical way of doing things. So you don't want to put it past the square root, because sometimes you guys might draw that square root symbol too long. And if you do, you might see 21 minus 5 and think it's 16, and then take the square root of 16 to get 4 and give me the answer of plus minus 4. See where I'm going with that? That's why they alleviate that issue by putting it in front of a plus minus. So your answer would just be -5 plus or minus 21. And that's a legitimate answer. That's a perfectly fine answer. There's nothing wrong with that. That's exact form. More often than not, textbooks will leave it like that. They don't give you decimals because nobody likes them. That was a joke. Okay. That make you probably haven't done that before, have you? But it's not much, is it? Let's do these are too easy. Let's just, okay. Now what happens? Because we can do these square root things only for so long until we run into a problem. So let's figure out how to deal with that problem. Like all the other numbers that you didn't know existed until right now. Yes, ma'am. It's kind of a good way of thinking it. Yeah, because you know you can't do it, no one will. Yeah. Well, guess what, ladies and gentlemen? There's this thing in your life that's just about to get a little bit more complex. And if you just think about it a lot, don't speak of it too much, and keep it in your mind, you can think of this imaginary land of peace, love, and happiness. Places where your motorcycle doesn't get soaking wet in the rain. Things like that. You get imaginary numbers. The square root of -1 is the imaginary number. There are now numbers that you didn't know existed. For example, a minute ago, we had problems where you took a square root over an equal sign and we solved for x. Well, what happens if you take the square root of a negative? Now you can. Because can't every number be rewritten as a complex, not complex, but a combination of numbers? Like 3 is 3 times 1. 4 is 2 times 2, or 4 times 1, things like that. Yes, sir. Yeah, a lot of times you'll see the eyes with a little tail to it, because this sometimes you forget to dot it. I do that with I also do that with my T's. I put a tail on a T because then it looks like a plus sign. So, do you have to write it like that? No, I usually do. What this is allowing us to do now is this. How do you take the square root of -27? In the past, when you guys did quadratics, remember when we talked about if that discriminant was negative, we said that there was no solution? Because there wasn't. When the discriminant was negative, when we graphed those things, you could still graph them. It just so happened that the graph never crossed the x-axis. So they have imaginary zeros where they occurs. Imaginary numbers are used a lot in electronics, ohms, resistance, things like that. It's just how things work back and forth numerically. So if you ever get into electrician stuff, you'll see it again. Personally, I can do most home improvement stuff, like a lot of it, like a lot. But electricity scares me because if I touch it wrong, I'm dead. Plumbing, I'm a really good swimmer. So if I flood my house, I'm gonna be okay. I can swim. But electrical, framing, that's easy. Make everything square. How hard is that? You make a right angle. Okay, I can measure it. It's not a problem. Wires, bad things. So, just like we had before, Bless you. Like we split apart the square root of, what was it, 8. We wrote it square root of 4, square root of 2. 27, I can rewrite it as the square root of -1, the square root of 9, and the square root of 3. What's the square root of 9? 3. What's the square root of -1? I. So my answer would be 3i root 3. You now have a whole nother realm of problems to deal with. Just think of it. Awesome. You can no longer say no solution because there's a solution. You just didn't know about it. Okay? There is a solution. This isn't any more difficult than what we have been doing. You just have to remember anytime there's a square root of a negative, you break out an I and you simplify it like you would any other way. That's all you have to really worry about. Okay? Also, when we deal with I values, what? Well, when you deal with I values, it's actually, I didn't write out screens at home. I is the square root of -1. Okay. What's I squared? -1. I squared is -1. Think about what you're doing. You're squaring the square root of jump squared is jump. Okay. What would I cubed be? What's that? No. All right, let's think of it this way. Watch this. Do you guys agree when you have something raised to a power, that just means it's multiplied by itself that many times? Okay. So that means it's I times I, I times I squared, right? What's I squared? -1, and then what's I? Square root of -1. So this is technically -I. It's not negative. It's the same thing as saying the -1 times the square root of -1. But what's the square root of -1? I. Okay, go again. It's new. Break it down here. What's I to the 4th is the same thing as saying I squared times I squared, right? You agree on that? What's I squared? What's -1 times -1? 1. Uh-huh. Just 1. Because that's -1 times -1. Watch what happens if you go to the 5th. Do you agree? Yes, ma'am. It's a very simple pattern that you'll have to recognize, yes. I to the 5th, isn't that I to the 4th times I to the 1st? What was I to the 4th? 1. And then I to the 1st is just I, isn't it? So I to the 5th is imaginary. And it starts back over. Think of the pattern. All you have to worry about is the pattern. I, -I, or -1, excuse me. -I, 1. Then it goes again, I. It rotates after every 4th. All right? You start with I, imaginary, and square root of -1. If you square that, you get -1. If you multiply -1 times I, you get -I. Then if you have -I, excuse me, then you'll have I squared, which is -1 times -1. you get 1. And the pattern just continues on. Think of it this way. Even if I wrote down I to the 25th, how many 4s go into 25? There's 6 of them, right? So this is the same thing as saying I to the 4th, I to the 4th, I to the 4th, I to the 4th, and then times what? I to the 1st. Because when you multiplying things together, you add the exponents. Every I to the 4th is equal to what? 1. What's 1 times 1 times 1 times 1? 1. Then what's 1 times I? I. Yep. Your best bet is to figure out how many times 4 goes into it, and then you just have to remember the 4. If you know 4 is 1, you only have to know 3 of them. If you know that I is the square root of negative 1, you only need to know is 2 of them. See where I'm going with this? It's not as complex as you think. Yes, ma'am. Yep. It starts over. What do you mean? With this value, the way that the signs rotate, imaginary, that's how it happens. 1 to the 72nd is also 1. But 77 to the 0 is, that's also 1. Okay. We'll worry about that later. Okay? This is going to allow us to do this. Oops. It's going to allow us to solve equations like this now. Watch. You will see that the process and how you start it, the process and how you go through it is all the same. None of that will change. Okay? So if I have 2x squared plus 3 equals negative 13, what's the first thing I'm going to do? Subtract the 3. Perfect. When I subtract 3, I get 2x squared is negative 16. Now what do? You divide by 2. Notice it's the same procedure. X squared is negative 8. Square rooted. You're taking a square root over an equal sign, so it has to be plus or minus. And what was the square root of 8? 2 root 2, but now it's negative 8, so it'll be perfect. Remember, all you are doing here is you're taking, you have the square root of, the square root of negative 8 can be rewritten as the square root of negative 1 times the square root of 8. We now know that the square root of negative 1 is I. And we just work it through from there. The rest of the problem doesn't change. None at all. Okay? You still have a plus minus thrown in there. And you still set it up the same as you work backwards from the sad bit. What's wrong? Oh. Yes, ma'am. That is quite literally all you have to do. Okay. Same deal.